Hello students, welcome to IMS GATE Academy. Can I start this? Okay. My name is Gopal. Today I am going to do the number of problems on analog circuits. But you also take the pen and paper. Whatever the questions are given, try to note down and solve the questions. And try to message the solution whatever you are getting now. Understand my point now? The subject is analog circuits. But in the analog circuits, this is the subject is common for electrical, electronics, and instrumentation. But what is the weightage is given for these subjects? First we can discuss. Then after I will start the problems. For ECE, 8 to 10 marks expectable. Even for the instrumentation also 8 to 10 marks. And for electrical, 4 to 5 marks expected from the analog circuits here now. We know very well in the analog circuits we got the topics of diode circuits, and also we got the bipolar junction transistor, and also we got the small signal amplifiers and feedback amplifiers, and then operational amplifiers, oscillators, like that. One by one you got it now. Today I am going to do certain number of the problems on diode circuits and BJT. Each and every problem is very good. You try to solve these questions and message the answer whenever you are getting. Understand now? Yes, we can start now. But first of all, I want to say one point. Whenever I am explaining the subjects, you try to listen with concentration. And each and every basic also I will explain while doing the problem. So regarding that problem, I will explain the basics also then you can do the problem very easily. Understand my point now? Now we can enter into the subject now. This is the first problem. How I selected the questions here, you see, initially I gave the diode circuit problems. In this problem, basic circuit only it is. I connected with a DC supply here now. Initially, you should understand how the diode is going to work. That is very important. Once you know the working principle of the diode, then you can do the problem very easily now. What is required here? Suppose I selected one diode here. This voltage we are going to call it as a anode voltage. This voltage we are going to call it as a cathode voltage, you know very well. First, just I want to give some information regarding the diode. Then after we can enter into the problem. Understand my point now? When diode will be on, we need to give anode potential positive or negative. What potential we have to give? That means VA and VC you got here now, two potentials here now. Those two potentials are to be given positive, first question. Otherwise, those two potential we need to give the negative potential. Otherwise, one is a positive or one is a negative. Which potential, how the potential is to be given to the what now? This diode is very, very important here now. We can give anode voltage positive, accepted. And cathode potential, cathode also we can give positive potential also. I will explain why. Even you are giving the anode with a negative potential and cathode with a negative potential, that will conduct. Sir, I don't understand. Clearly you give the clarity. Yes, I will give. If anode voltage is greater than cathode voltage, then diode is going to work. That is the main condition. Try to catch my point. If VA is greater than VC, then only diode is going to work. Suppose I am giving anode potential is nothing but 5 voltage for example. Cathode potential is given the 2 voltage only. One is a positive potential, second one is nothing but that also positive potential. But one is a higher, one is a lower, I gave it now. In that case, diode will be on state only. Catch my point. Because VA is greater than VC only. I said just now, suppose I am giving VA 5 voltage, VC is nothing but the 2 voltage I gave it. Now diode is a on or off. If I ask, what you can say? 100% it is on state only. Sometimes students will get a doubt, sir, how you can say both are negative, sir? You watch it. Suppose I am giving here anode voltage is nothing but -2 voltage, for example. Cathode voltage I am giving the what now? -5 voltage, for example. -5 I gave it now. Now diode is forward bias or reverse bias? Even in this case also diode is forward bias, because -2 volts is greater than what now? -5 voltage. Anode voltage is greater than cathode voltage only here also. That is why in this case also diode is going to work. Next one, suppose I am giving one is a positive, one is a negative. For example, I gave it anode voltage is nothing but 2 voltage I gave it, for example. Cathode voltage I gave it -1 voltage only. Now diode is a on or off. If I ask, any students can say 100% it is on state only possible, because anode voltage is greater than cathode voltage only now. So what we could understand, whenever anode voltage is greater than cathode voltage, then diode will be on state. Otherwise, it comes to the what now? Off state only. And few more points you have to understand. Diode can have the what now? In the problems, he will give two cases only now. Diode under ideal case, when diode is non-ideal. Non-ideal means that can have some drop only now. And ideal case means what is the meaning? The internal resistance of the diode is considered 0 only now. When diode is forward bias, diode must be replaced by short circuit. When it is an ideal case only now. When diode is a reverse bias, it can be what? Replaced by open circuit only, if it is a reverse bias. These two conditions very important for the what? Ideal case only. Non-ideal means what I said, voltage across diode is to be taken as a 0.7 voltage. When diode is a reverse bias, it will be open circuited. That is in the reverse bias only now. That condition only we are going to apply in this particular problem only now. Understand my point now? Yes. Next one. Now I will do this problem now. How to do this problem? Please watch it now. In this case, diode is connected, certain number of the resistors are connected in this problem, and sub voltage is also given. One has a 10 voltage, second one is nothing but the 5 voltage only. How we can solve this question? What you have to do here is, this circuit we must simplify. What way we can simplify, sir? Initially, we need to assume right hand side portion is an open circuit only now. Whenever it is an open circuit, Thevenin's equivalent circuit you try to form left hand side. In the same way, this side also, right hand side also, this is open circuit again. Whenever it is an open circuit, you get the Thevenin's equivalent voltage. Thevenin's voltage you find from the what now? Right side. Thevenin's voltage you find, because this is the open circuit, second case only now. And also find the Thevenin's resistance only now. How we can form this, you watch it. From this one, I want to find VT1, RT1, I want to find. VT1 means Thevenin's voltage in the first case only now. Thevenin's resistance in the first case I want to find. In the same way, this side also Thevenin's voltage in the second case, and also Thevenin's resistance in the second case I want to find here now. RT2 also we can put here, no problem there. How we can find Thevenin's voltage? VT1 I want to take here now. VT1 means voltage across this 20K is said to be VTH only. This voltage drop I can call it as a Thevenin's voltage only. How we can find this voltage? According to the voltage divider formula, we can find this now. VT1 equal to 10 voltage into 10 into VT by 10 into 20 according to voltage division formula. 20 by, I can note down here, 10 plus 20, 30 kilo ohms is available. Kilo cancel here now. 0 cancel. 20 by 3 is available here now. 20 by 3 is available. But 20 by 3 equal to what voltage is available here? That voltage comes as, whenever the simplification is made, 6.67 voltage is available here. 6.67 voltage is available. That is VT1. In the same way, we need to find the RTH also. Thevenin's resistance. In the first case, I want to find. How we can find that voltage resistance? I am in need of RT1. To find the Thevenin's equivalent resistance, wherever the voltage source is given, that must be shorted. That must be shorted. Whenever this voltage is shorted, 10K and 20K are in parallel. That means the view is to be made this side. When the view is made this side, how these two are there? These two are connected in parallel. From this parallel connection, directly we can measure the required value. I say we can measure RT1 from 10 into 20 by 10 into 20 divided by 10 plus 1, 10 plus 20. 10 plus 20 is nothing but 38 is available. Even here also what we are going to get? 0, 0 cancel, 20 by 3. 20 by 3 equal to how much? 6.67 kilo ohms it is available. 67 kilo ohms available. 6.67 kilo ohms it is available. In the same way, R2 value, what now? VT2 and RT2 we need to find here now. Thevenin's voltage in the second case. How we can find this voltage? 5 into 10. 5 into 10 divide by 10 plus 10 is nothing but the 20 here now. I can cancel 0, 0. We are going to get 2.5 volts. 2.5 volts it is available. So VT2 is nothing but 2.5 volts here available only. In the same way, we need to find out the what now? Thevenin's resistance in the second case also now. 10K, 10K are in parallel whenever the source is shorted here now. In this case, I am going to get the RT2 as 10 parallel to 10 we got here now. Then we are going to get the 5K values available here now. In that way, we can find the VT1, RT1, VT2 and RT2. After getting these values, we need to draw the what now? Equivalent circuit only now. By using the equivalent circuit, we can find the values of what? Drain current, and also we need to find the voltages also. The current ID in the diode is required, and also voltage V0 also it is required here now. These two values are needed here now. That means the circuit shown in the figure, the current ID through the diode is required, and also V0 is required. These two parameters are more and more important only now. But I can say, by using this, how we can draw the equivalent circuit? VT1 is nothing but 6.67 here. 6.67 volts we are getting here now. And also we got the resistance. The resistance we can draw, I can draw 6.67K here available. That much resistance is available. After putting that resistance, I can connect the diode here now. The diode is connected in this side. With the diode, I can connect the same side only now. The diode is connected here now. And also we got the RT2 we got. RT2 is nothing but the 5K. This is 5K resistance. And voltage we got as a what? 2.5 voltage only. So such a way, finally, the network is formed. Now you please tell me this diode will be on state or off state. But anode side we are having the 2.5 voltage only. Cathode side we are having the 6.7 voltage only. Anode voltage is less than the cathode voltage we are having in the problem only. In that case, 100% this diode is off state only possible. Whenever the diode is in off state, it doesn't conduct. It can act as a what? Open circuit only. When diode is in open circuit, we are going to get the diode current of how much? 0 amperes only possible. So I say anode voltage we are finding the what now? Less than the cathode voltage. That is why current passing through this diode will be 0 amperes only possible. 0 amperes only possible. That current only now. And but when the problem is asking V0 also, and also find the V0 value. How we can find V0 value? Whenever the current is not passing, V0 is nothing but the voltage across the 10K only now. Voltage across the 10K, it is given already. How much across 10K? 2.5 voltage only we are getting here now. So that voltage is nothing but the V0 voltage. We can say V0 equal to 2.5 voltage is available. Finally, we are getting voltage of 2.5 volts. and the diode current is nothing but the 0 amperes only possible. So, which option is correct from this one? Option C is correct from this problem only now. Such a way the problem will be done here. I think the students followed this question clearly. Yes, we can go to next question. Yes, this is the second problem. But this problem I will read here now at first, then after we can start the work. A voltage signal 10 sin omega t is applied to the circuit with ideal diodes as shown in the figure. The maximum and minimum values of the output waveform V out of the circuit are respectively. In the problem is asking to find out the minimum output voltage and also maximum output voltages is asking in the problem only now. How we need to find out these two voltages is more important only now. How we can find these two voltages? You watch it here now. First of all, what is this network? What network is given in the problem? The problem is connected with the two diodes and also two batteries and also AC input is given. This is nothing but the clipping circuit only now. But I think the students know well about the clipping circuits. Why clipping circuits are used? What is the clipping circuit means what? To remove the some portion of the signal at the output. Some portion of the signal if you want to eliminate, you want to truncate, at the time we are going to use the clipping circuits only here now. But these are the clipping circuits what two diodes are given. What is the name of this circuit? But how many types of the clipping circuits are there? There are two types of the clipping circuits are there. One is said to be what? Diode clipper. Second one is nothing but the transistor clipper. You know very well now. Diode clippers are again two types, you know very well. One is nothing but the series diode clipper. Second one is nothing but the shunt diode clipper only now. And also we can say one is nothing but in the shunt diode clipper we are having here what? What model here now? Two level clipping circuit is given now. Two level clipping only. Two level clipping means clipping is done at the top and clipping is done in the below also now. Such a way it is done, it is called as a what? Two level clipper only now. Anyhow, the given circuit is two level clipping circuit. What now? Clipper only we can say only now. How we can find the required value? Maximum and minimum values of output waveform. What now? Output is required here now. But two diodes are ideal or non-ideal? In the problem it is given. 100% it is given. Those two diodes are ideal only. I am going to give some time. Please try to tackle this question. Please start doing this question now. If you are getting answer means please message it. I can understand how many students are in a position to do these questions now. Please start. Just try this question to get answer. Initially work is required from your side. Any students can do this question or not? How to do this problem? Anybody can do this question? I'm not getting the response from any students. How we can do this problem? Please watch. Maximum and minimum output voltages are required. Initially what I did, the given waveform is nothing but 10 sin omega t is given. 10 sin omega t is given here now. And also here the 10 sin maximum output voltage when you want to find means V needs to be taken 10 sin omega t only now. 10 maximum voltage I want to take it as a 10. This is the maximum voltage. By using this maximum voltage we need to get the what now? Maximum output voltage only now. When 10 volts supply is given, which diode is on and which diode is off you identify. Because of the 10 voltage, D2 is on state only. Why D2 is on state here? Why D2 is on state? Why this D2 is on state means the diode is forward bias only here now. The diode is forward bias. Okay. Yes, because of the connection of this maximum voltage of 10 volts, which diode is on and which diode is off, you check it. Which diode is on? D1 is reverse bias because this is N type, this is a P type material only. This is negative, this is given with a 10 voltage only. Positive is given to the negative only now. Positive is given to the negative means 100% diode D1 is reverse bias only. I can say when Vi equal to 10 volts to find the maximum voltage only. When Vi equal to 10 voltage, D1 is reverse bias here. The diode D1 is reverse bias. This diode is a reverse bias here now. What about the diode D2? Because of this 10 voltage, positive is given to the positive only here now. The negative is given to the negative only here now. 100% this diode is forward bias, we can say. I can write D2 is forward bias. Whenever D2 is forward bias, D2 will be short circuited only because ideal diode only. Whenever diode D2 is a short circuited here now, whenever it is a short circuited here now, what is going to happen now? What output is available? Only 4 volt is available. Only 4 voltage only. Why it is 4 voltage? Drop across this diode is a 0 voltage only. Battery voltage is nothing but the 4 voltage only. In this case, we are going to get V0 equal to how much voltage? V0 is available. This voltage we are going to take it as a maximum voltage only. This is the maximum voltage it is available. That means when you are giving the positive potential of the 10 voltage, 100% D2 is on and D1 is off state only. In that case, we are getting the what now? V out of 4 voltage only. In case, if you want to find out the minimum value of V0, you think it's so. Minimum value of V0. In the place of this 10 voltage, what we need to connect here now? Minus 10 voltage, we need to connect only now. What happens towards? I connected with when Vi equal to minus 10 voltage, I selected here now. Minus 10 voltage. Why Vi equal to minus 10 voltage? In this case, I want to check this diode is, which diode is forward bias, which diode is a reverse bias, you need to identify. Then after we have to calculate output voltage only. The output which is available from that circuit will be what? Minimum value only here now. How we can get? The network we can draw in this case like this only now. I selected the supply. This supply is what? Minus 10 voltage. This is minus, this is the plus I have taken. This is a 10 voltage I connected only here now. That much voltage I gave it. Then after resistance of 10K here existing, I connected 10K resistance. That resistance I connected as it is only now. And which diode is on? In the second case, minus 10 voltage whenever you are connecting here now, D2 will be off state only because it is a reverse bias. This D1 is a forward bias only. So D1 must be short circuited, D2 must be open circuited only. I can redraw. D1 is short and connected with a source. This is connected with some source. What voltage we are having? 4 volts we are having here now. This is 4 volts. This is with a minus and plus. Resistance of how much we got here now? 10 kilo ohm we got here now. That 10 kilo ohm I connected as it is. But second diode will be off only now. Second diode is off. When second diode is off means it can be open circuited only now. We need to find what output voltage is available here. What V0 is available here. That is very important. That V0 is to be taken as a what? Minimum voltage only available here now. Minimum voltage is available here now. How we can find this minimum voltage? Just calculate the value here now. Yes, we can find the V0 minimum here. Already we got V0 maximum is nothing but 4 voltage here now. How we can find V0 minimum? That is more important now. The equivalent circuit we can plot in this way. That means whenever the minus 10 voltage we connected to this circuit, diode D2 is offset is possible. It is a reverse bias. So it is open circuited only. D1 is forward bias. When the D1 is forward bias, it must be replaced by short circuit here now. In this case, I wish to find out the V0 value. How we can find the V0? By using the nodal analysis, we can find any sort of way we can do. Suppose I selected here nodal. This voltage is nothing but same V0 only here now. How we can apply the nodal? Away from the node, you take it now. This current plus this current equal to 0 only. Summation of all the currents equal to 0. What current will flow across 10K? V0 minus of minus plus. V0 plus 10 divide by 10K here. KK cancel here now. And what about this current? Summation of all the current 0. V0 minus of minus plus V plus 4 divided by 10. That equal to 0 only. From this equation 10 and 10 we can cancel. From this one we need to find out the what? The value of, we need to find the value of what? But V0 minus of minus plus V0 plus 10 divided by 10K we are getting here now. And here V0 minus of minus plus V0 plus 4 by 10 we are getting. 10 cancel. And find out what is the V0 is available here now. That V0 is available as, a, from this one we can find directly 2V0 here, directly we can find y. 2V0 plus 14 equal to 0 only possible. And finally V0 is available, minus 7 voltage is available. Now from this circuit we can understand this voltage we are going to call it as a minimum voltage only. This is minimum voltage. So maximum voltage we got from the what now 10 volts maximum supply is nothing but the 4 voltage only. When VI equal to minus 10 voltage if it is taken, minimum voltage is available minus 7 voltage only now. So which option is correct from this one? Option 4 is correct only, you can say. 100% option 4 is correct from the problem only, you can say. Such a way we can do. Next problem. Yes, this is the third problem. The first problem, basic circuit only. By means of giving the DC supply directly, we got the answer. Second one is nothing but the clipping circuit I gave it. In the third problem you watch, diode is connected with AC and DC only. Both are connected. AC supply of 10 sin omega t is given, DC equal to 6 voltage is given. What is asking in the problem? We can see now. If thermal voltage at room temperature is 25 millivolts, then current IAC flows through the silicon diode, D will be. What is asking in the problem? There is a diode. This is connected with what now? AC and also DC. Both are connected here now. Both are there. Is asking to find IAC only. Because of AC and DC superimposed, what now? Superimposed AC and DC waveform is available from the given network. But in the question is asking only IAC, how much only now? How we can measure IAC? That is very important. Anybody can tackle this question? You take some time and try to do this question now. What way we can do? Just anybody can do this question? Which option is correct? Anybody? Anybody can do this question. In this problem, just I will explain at first. It is better to explain only here now. Whenever AC and DC are connected with a what now? Any diode you think it's so. Directly we cannot do this question. Under DC analysis, superposition theorem, very good. One student gave superposition theorem, exactly correct only now. That means under DC analysis, you need to do some work. Then after under AC analysis, we need to do the what now? Work only now. And finally, we are going to get the required answer only now. What is required under DC analysis? What is required under AC analysis? We can see only now. Initially, what I did under DC analysis, I selected under DC analysis. Under DC analysis, initially I want to apply DC analysis only. Whenever you are applying the DC analysis, what you must do, wherever AC supply you got, that must be shorted only now. AC supply means voltage source, AC voltage source, if you got, that must be short circuited now. If you got the what now, any current source of AC, any current source is given, any AC means you can what now, open circuit only now. In this case, anyhow, DC source is to be taken, AC source must be shorted. Then I can get the circuit in this way. There is a voltage source. That voltage source is nothing but 6 volts. Here connected with 6 volts only now. And also what is given, 2 kilo ohm and 2 kilo ohms here given. 2 kilo ohms, this I will connect as it is only now. From this one, what I can do, 2 kilo, I have taken as it is for example now. 2 kilo ohms. First we can draw that network. Then after I will explain how to do this now. One is a 2K here. One more is nothing but the 2K is given here now. 2K here given. Diode is connected. The diode I want to take as it is only now. The rest of resistors can be taken as it is only now. This is 4K and one more is nothing but the 2K is given here now. This is the network we got here now. That network we got it now. Sir, what we need to find by using this? You need to calculate IDC value. AC and DC are given means under DC analysis, IDC is required. Why that IDC is required, you can understand shortly now. For the time being, what I wish to say, you need to calculate IDC value only. How I can get? I can simplify this network only. According to the Thevenin's theorem, we need to simplify only now. What voltage will be existing here now? Whenever it is an open circuit, what VTH is available? You need to find. How we can find? Thevenin's voltage we need to find. That Thevenin's voltage we can get 6 into 2 by 2 plus 2, 4 only now. What voltage is available? 12 by 4. 3 voltage is available. And 2K are in parallel. By using this, I can find the what now? Thevenin's resistance of how much? 1K I can get here only now. Yes, we got Thevenin's voltage of 3 voltage and Thevenin's resistance of, we got the 1K. Then the circuit can be redrawn in this way. This voltage is nothing but 3 voltage here. I connected 3 voltage only. And we got the resistance. What resistance we got here now? 1K resistance is existing. That resistance I connected here now. And also diode I connected as it is. I don't want to touch that diode. And 4K and 2K are in parallel. But whenever the what now 4K and 2K are in parallel, you simplify. That means 4 into 2, 8. 4K parallel to 4 parallel to 2 only, 2K only now. At the time 4 into 2 by 4 plus 2. It is available exactly 1.33 kilo ohms it is available. 1.33 kilo ohms are available. I can write the resistance is nothing but I'm drawing here now. 1.33 kilo ohm resistance we are getting only now. That resistance I connected as it is only now. This is the network finally we got here now. In this case, we need to calculate what amount of the current is passing this side. That current is nothing but the IDC I can write. DC component of current is passing in this network only now. But diode should not be considered here now ideal only now. In the problem it is not specified at anywhere the diode is ideal, it is not given now. The voltage across this diode is to be taken as a 0.7 voltage only. Whenever this is the 0.7 voltage, you try to calculate what amount of the DC component of current is passing in the network, you try to calculate. How that voltage we can find, that current we can find, voltage by total resistance only. Voltage is nothing but the 3 minus 0.7 divide by total resistance. 1K and 1.33 are in series only, but a 4.33 is available here. 2.1 plus 1, 2.33 is available, 2.33 K is available. Use the calculator, you will get the IDC. What IDC is available from this network? Anybody can give? IDC equal to how much? 0.987 is available. 0.987 milliamperes of current is possible here now. So, under DC analysis, whenever a problem is given with AC and DC, in that case, under DC analysis, we have to find out the what now? IDC value. That value you keep it only now. Sir, what is the point of finding these IDCs are? Because AC current, AC component of the current, if you want to calculate means 100%, it is required IDC value only now. Understand my point now? Yes, anyhow, we got this value. Now, what I wish to say here now, I wish to redraw the diagram. Under AC analysis, I will do here now. Under AC analysis, just I want to use the AC analysis only now. Under AC analysis, what you have to do here now? Wherever DC source is given, that must be shorted. AC source must be taken as it is only. One more point, what is required? Wherever diode is given, that must be replaced by dynamic resistance only. Catch my point. Under AC analysis, wherever DC source is given, that must be short circuited now. Wherever diode is connected, that must be replaced by dynamic resistance, I say. What I said here now, in this case, please watch what is given before. This problem is given what now? AC source it is given. DC source we are short circuiting here now. DC source we are short circuiting. If you are short circuiting, this one means what is VTH is available, you find from this one. Thevenin's voltage you find. Resistance will be same, it will not be different only now. Same as that value. How much you are getting last one? 1K we got. Same 1K will be existing now. I say Thevenin's voltage we can find 10 sin omega t, 10 sin omega t into 2 divided by 2 plus 2, 4. 2 plus 2, 4. Whenever 2 times you cancel, Thevenin's voltage is available here. 5 sin omega t is available. That much amount of the Thevenin's voltage is available. Now I say, while drawing the what now AC equivalent circuit, this voltage is to be considered. Resistance 2K, 2K are in parallel. The equivalent resistance to connect. I say, you watch, you can understand clearly. This network, what I did, I connected with a AC source. That AC source just now we got 5 sin omega t, we got already. That I will connect. 5 sin omega t we got. Wherever DC source is there, that must be short circuited, I said already. Already you got the resistance here now. What resistance you are having here now? 2K, 2K in parallel. When it is in parallel, we are going to get 1K resistance here. That I will connect as it is. That resistance is taken as it is. And also, please watch. In a problem, it is given diode is existing. Wherever diode is given, that must be replaced by what I said, dynamic resistance only. Yes, I will connect. That is connected with one resistance. This is nothing but RD value. RD is nothing but dynamic resistance only. Then after, please watch once. And also still what is given? 4K and 2K are in parallel. That value we got already, 1.33K only. 1.33K. I will connect. 1.33K. That is the resistance we got. This I connected such a way. Finally, we got this network. But I want current through the diode. This current only, current through the diode only. What current? IISc. This is IISc only. That current we need to calculate. But their unknown value is what? Dynamic resistance is unknown. How we can find? From the electronic devices and circuit, dynamic resistance formula is there now. RD equal to eta into Vt by ID. ID means under DC analysis, what current we got, that is to be placed there only. In a problem, eta value, how much it is given? Please check it once. Already eta value is given or not given? Not given at anywhere. Not given means you try to assume that value is nothing but 1 only here now. So I will take, and VT thermal, this is nothing but 25 millivolts is said to be thermal equivalent of voltage only, VT value. I wish to connect, please watch. This eta is to be taken 1, if not given now. Thermal equivalent of the voltage is given 25 millivolts. That voltage I want to connect as it is. 25 millivolts I have taken as it is only. And also we got diode current we got under DC analysis. Under DC analysis, what amount of the current we got already? IDC is ID only now. 0.987 milliamperes. Yes, I will connect 0.987 milliamperes. That is nothing but dynamic resistance only. That dynamic resistance is more important now. How much value is possible from this? What amount of dynamic resistance is available? That you calculate. Use calculator and tell me what is the dynamic resistance is available. That value comes as a 25.329. 25.329 ohms it is available. That much resistance is available. Once we got the what now RD value, directly we can measure the what now IISc, current we can measure. How we can measure the current? Yes, we can note down. I want IISc. How we can find IISc? Voltage by total resistance only. What voltage we are having here now? That voltage is nothing but 5 sin omega t, 5 sin omega t divide by total resistance. What is the total resistance here? 1K plus RD. RD is nothing but 25.329. 329 we got. And also 1.33 K resistance we got now plus 1.33 K resistance now. Use calculator and please tell me what is the value it is available. IISc here. Just use the calculator and tell me what IISc is available. What IISc is available. When you are using the calculator means 2.123 it comes. 2.123 and also sine of how much? Omega t is there now. Sine omega t. Just use the calculator. That comes with, that will come with what now? Milliamperes only, mostly it comes. That much amount of the current is available. But options you watch, what are the options are given here now? Here 10 sin omega t milliamperes, both C and D, 5 sin omega t, 2.15 is given, 2.15 here given now. But here we are getting the what now? 2.12 approximately, that is equal. So which option is correct here now? Exactly we can say option C is correct from the problem only. You can say approximately it is equal to what now? This value only now. So when you are given AC and DC, the methodology is applicable only. What I said? AC and DC given means initially you take diode under DC analysis only. Under DC analysis, what we are finding? ID value. ID means current through the diode. DC analysis we applied. Then after what we are doing? Under AC analysis, wherever the DC source you got, that you are short circuiting only now. Wherever the diode is given, that is replaced by what? Dynamic resistance only. Once the dynamic resistance you got means you can find out the current only. How we are calculating the dynamic resistance? I give here now. Dynamic resistance whenever you want to find means eta into Vt by Id we have taken. Eta value when it is not given means you take it as a 1 only now. Sometimes they will give eta value 1 or eta value 2. Then we can substitute those values only. Once you got the RD value, IISc we can find directly only now. This is the methodology to find out the current in the what now? This diode when given AC and DC values only now. We can go to next problem. Yes, this is one more problem. This problem is from the Zener diode here now. By using the Zener diode, it is given here now. What is asking in the problem? Once you watch the now, how ID is equal to the value? How ID is equal to IDC star? Yes, ID is nothing but what now? But under DC analysis, we are going to get the what now? IDC only now. IDC or IDR both are same. Capital ID or IDC or both are same only now. We can denote the symbol IDC. Otherwise, we can put it as a I suffix capital D also. Understand my point now? You can give the any name. Capital I, small d is not allowed. Exactly. I suffix capital D is allowed. Otherwise, I DC is acceptable only now. Understand my point now? But we can denote any letter now. Understand now? That way we can find. Yes, next question. Any doubts, anybody? Anybody has got any doubt regarding that problem? If you got any doubt, please arise. The one student asked how ID is equal to the DC value. That only. Under DC analysis, if you calculated, you are going to get the what now? IDC value or ID. Both are same only now. It is not different only, I can say. Understand now? Yes, next question. For the network shown in figure, the range of RL that will result in VRL being maintained at 10 voltage is. This problem is from the Zener diode. This is the problem from the Zener diode only now. In this problem, what is asking to find? The voltage across the load being maintained 10 voltage only. That means voltage across this load, the problem what is given you was, voltage across the load is maintained 10 volts. Is maintained 10 voltage means VL equal to what? VZ only, he says. When VL equal to VZ, you find out the range of RL only. The range of RL means in the problem what is given? Minimum value and maximum values are given. Here we are in need of RL minimum is how much? RL maximum is how much? That is the question from the given problem only now. What way we can find RL maximum and RL minimum, we can see. If possible, plus you start doing this problem. I am giving some time. Please try to tackle it first. If you are getting answer means very good. Please message the what now? Answer what you are getting by solving this problem. First, you make an effort to get the answer for this question. What minimum value of RL is required? What maximum value of RL is required? That you try to find from the given network. Anybody can message answer for this? Any student can message. Any chance? Maximum load resistance, minimum load resistance required from this problem. What way we can calculate? That is my question. Just to take some time and try to give answer. Please message. Then I can understand whether you followed or not followed the Zener diode. You might have prepared already for the Zener diode. How you will give answer? Just I want to check. Anybody? Shall I do then? Yes, you watch. I will do otherwise. Supply voltage is given 50 volts. VI is given 50 volts it is given. One series resistance is connected 1 kilo ohm only. Voltage across Zener is given 10 volts. IZ capital M is given. IZ capital M means what? Maximum Zener current passing. Maximum Zener current passing is nothing but 32 milliamperes only here now. Load is variable. Load is variable here now. We need to find the RL minimum and RL maximum only. Initially, we can make an effort. How to find RL minimum here now? How we can find RL minimum? Catch. Just I will ask the question. Please try to give your answer now. Initially, I want RL minimum. RL minimum initially I want. RL minimum whenever you want, IL is maintained in the circuit maximum or minimum. When the resistance is a minimum, load current will be maximum only possible. I can write when RL minimum is maintained, IL of maximum is possible in the problem. IL of maximum only possible. How I can get the IL maximum means we can see. I will give the now. Initial I am giving here now. RL minimum means IL must be maximum required. Next point. Here, this current I wish to take it as a IR is given. Okay, we can put I suffix R. Across this resistance, this IR is passing. IR is a constant or variable in the network? Is it a constant or variable in the network? That is my question. So, input voltage is constant, 50 voltage. What is this node voltage? I asked. What is that node voltage? That node voltage is nothing but the voltage across the Zener only. Now. What is that Zener voltage? 10 voltage we got. So, catch my point. Before the 1 kilo ohm, 50 volts here constant. After 1K, VZ value 10 volts, this is also constant. Resistance also constant. Current passing through the what now 1K will be constant only. It will not vary. So, IR is constant. IL is a variable because with the change of RL, IL also changing. Now, initially RL minimum is maintained. Hence, we say IL of maximum is passing through the network only now. Catch my point. And whenever the maximum load current is passing, can you say IZ is a maximum or minimum possible? Once this current is maximum, this current must be what? Minimum only required. IZ must be minimum only possible. The minimum current is possible now. Now we can find, to find the, but not to find the resistance, try to catch, to find the RL minimum, we need to find the IL maximum. To find the IL maximum, IR is a must. Without IR, I cannot determine IL maximum. So I say IR to find, I am writing here now, to find RL minimum, I am doing the work. This model question is a very important gate point of view. Very, very important, this type questions in the gates. Asking, repeatedly asking now. How we can find the RL, but how we can find the IR? Input minus output by what now? 50 minus 10 by 1K. We can put directly. I can write current through the resistance is nothing but input side I got 50. This voltage is 50 minus this voltage, node voltage we got as a 10 voltage here. Divide by resistance is nothing but the 1K. I am putting this is nothing but the 1K value only. And finally, what IR is possible? 50 minus 10, 40 milliamperes of current is passing this side. This current is 40 milliamperes only. Yes, we got IR value constant. That will not be changed because before the resistance, input is a constant, node voltage also constant only. What about IL maximum? IZ minimum is required. Is it given in the problem or not? You check it. IZ minimum is given or not given in the problem. Please check it. In the problem, it is not given. IZ maximum only given. When IZ minimum is not given means we need to assume it is nothing but what? 0 milliamperes only. 0 only. If it is not given. If it is given, you must consider that value only now. Student will get one more doubt. Sir, when IZ minimum is a 0 if it is taken, directly what now? It becomes a series circuit only now. Totally series circuit. Diode will be removed only totally, sir. No, that is not correct. IZ minimum means what is the meaning exactly? Very less amount of the current is passing across this Zener diode. That current we are neglecting only. When the value is not given, we are neglecting. Practically, it can flow some amount of the current. That current is nothing but very, very small, we are assuming. So, what I wish to say, what is IR if I asked? What is IR if I ask? You can say IZ minimum plus IZ minimum plus IL maximum only. IL maximum only. IZ minimum plus IL maximum. By using this formula, we can measure the what now? IL maximum. In the problem, I suffix R, we got 40 milliamperes. 40 milliamperes. IZ minimum is 0, we consider, neglected only this current. This side IL maximum we are getting. IL maximum we are getting. And finally, what is IL maximum? We can say IL maximum is nothing but 40 milliamperes only. This is 40 milliamperes is possible. That is IL maximum. Why we are calculating that the IL maximum, sir? For the sake of finding the RL minimum only. How we can measure RL minimum, sir? You watch. We can find RL minimum equal to RL minimum I want. How we can find? Voltage by current only. What voltage we got here now? VL, but output voltage is maintained 10 voltage only given. That means VL equal to VZ. I can write same 10 voltage here. What current is passing? 40 milliamperes. I can put here now 40 milliamperes. Milli, 10 power minus 3. I can cancel 0, 0. Finally, what is available? 0.25, 0.25 K. 0.25 K is possible. 0.25 is approximately equal to what is available? 250 ohms it is available. 250 ohms it is available. So we got RL minimum is nothing but 250 ohms it is possible now. But directly by watching the what now, by after getting the RL minimum, directly we can say which option is correct here now, we can say easily now. But that is not the right method. We can find RL maximum also from this problem only now. Anyhow, I think students followed how to find the RL minimum. Are you getting this? Now we can find the RL maximum also. How we can find? Please watch. I will do. To find the RL maximum, I will draw the network. To find, but I want to find RL maximum here. I wish to find the RL maximum. How we can find the RL maximum? Just we can draw this diagram again. 1K and 50 volts we got here now. I will draw the now. Just I will draw. Here there is a resistance. There is a Zener diode. We got the Zener diode this side. And the load is connected here. That I will connect here as this. This is a variable resistance RL. This voltage is nothing but V0 here. This voltage V0 only. The voltage across Zener is taken VZ. In the problem it is given, what is the VZ value here given? VZ is given 10 volts. I can take here now, VZ is nothing but 10 volts here given. And the series, this the supply voltage is, how much it is given? Supply voltage is given as a 50 voltage only now. This is 50 voltage. This is 50 voltage. And resistance is connected here. And resistance is connected here. 1K. Yes, we can connect 1K. This is 1K. Yes, this is the question now. And also one more is given in the problem. What is given? And IZ maximum is 32 milliamperes. IZ maximum is given 32 milliamperes. Yes, I will connect 32 milliamperes. Yes, this is given in the problem. We are in need of this resistance. RL is required. Already we got RL minimum. I want RL maximum only. This is RL maximum. We can say in this problem, the current passing through the 1K is nothing but IR, no doubt. This the current is nothing but, this the current is constant. What current we got before, same current is to be taken here now. This side current passing through this resistance is nothing but IL. IL is a maximum or minimum? RL maximum we are maintaining. Whenever the resistance we are maintaining the maximum, current of minimum only possible. IL minimum is possible. IL minimum. As resistance is large, current will be less only available. This current is nothing but IZ maximum only. This current is taken IZ max or IZM. We can take that value required. Already we got IR. This value will not be changed. That is taken as is. How much we got already? Already we got IR is 40 milliamperes. Yes, I will connect 40 milliamperes here. This is 40 milliamperes only. No change. IR is 40 milliamperes. And next one, IZ maximum is given 32 milliamperes. I can find IR equal to IZ maximum plus IL minimum only. Addition of these two currents will give the IR itself. I say IR is nothing but IZ maximum plus what is possible? IL minimum here. IL minimum here now. IL maximum only, sorry. IZ maximum plus IL minimum only possible. These two addition will give the required answer. IR equal to how much you got? 40 milliamperes. We know doubt. 40. Finally, milli we can put. IZ maximum 32. I want IL minimum here now. So IL minimum equal to, we can say directly, IL minimum equal to, yes, IL minimum equal to 40 minus 32, 8 milliamperes here possible. This current is 8 milliamperes possible. Once you got the current, you can measure the what? Resistance. RL max I want. RL max is nothing but V naught by what? IL minimum. V naught equal to 10 voltage is given in the problem. Same 10 I can maintain. IL minimum is nothing but 8 milliamperes only. 8 into 10 power minus 3 is available. Whenever you are using the calculator, how much value is available? Please tell me this value. How much it comes? It comes 1.25 K. It comes 1.25 K is available. That is RL maximum. Understand? So options are given. Please watch. So RL minimum is nothing but the 250 ohms, and also we got the what now? RL maximum equal to 1.25. 1.25. Option A is correct for this problem only. In this way, we can find the resistances of maximum and minimum only. Understand? I think the students followed this problem. The model problem is very, very important gate point of view. Maximum times it is repeating such type of questions in the gate. Understand that? Please try to practice this question more and more. Followed this. Shall I go to the next question? Next problem. Yes, this is the next question. Yes, initially I want to give in the hands of the students only now. Anybody can do this question? Initially, I will not open my mouth. Just I will keep silent. How many students can give answer for this question? I will see. Which option is correct? Is it A or B or C or D? Which option is correct? Anybody can do this? Anybody can give answer? Very direct question, this one. Just try this and tell me. Choose the correct statement regarding both circuits 1 and circuit 2. Two circuits are given. Circuit 1 acts as voltage doubler. Circuit 2 acts as voltage tripler. Circuit 2 acts as a voltage quadrupler, V0 to 4 Vm only. These all of the above. Yes, please try this. Which option is correct? Anybody? Just I will wait. Please try to tackle this question. You try to give answer. Which option is correct here? Anybody? Anyone can give answer for this question. Options are given for. Which option is right? Please try to identify this. A or B or C or D. Anybody? Nobody is responding. Shall I do otherwise? Shall I do this? Yes, so please watch. This is circuit. Which option is correct? We don't have an idea at first. First, circuit 1 I have taken here now. Circuit 1 acts as voltage doubler, it says. Voltage doubler means, if you are giving the input Vm means output must be 2 Vm. 2 Vm you got means it is a voltage doubler only. But in this case, suppose here the Vm is given. Suppose we are getting the what now positive pulse here now, for example. Suppose you got the positive pulse, for example. Maximum amplitude is Vm. This amplitude of the what now waveform is a Vm only here now. Which diode is on in the circuit 1 you identify for the given waveform. When the positive pulse is given, D1 is forward bias. This diode is on. What about diode 2? You check it. When the positive pulse is given, diode D2 comes to what now? Off state only possible here now. It will come to off state. Once the D1 is on, how the polarities are available here now? This is forward bias. It can give the what now? Polarity plus and minus only. Positive is given, plus minus is available. Here the maximum voltage is a Vm, and it can give voltage across C1 is available Vm only here. Maximum voltage is available across C1 only. That's my point. Once we got input of the diode C's positive pulse, which diode is on? You identify at first. Which diode is on? D1 is on and D2 is off. Why D1 is on? It is a P-type material. It is an N-type material. It is a P-type material. It is an N-type material. Positive is given to the positive means 100%. It is a what now? Forward bias only. That is why it is on state. Why D2 is off? Why D2 is off? Why D2 is off means negative N-type material is connected to the what now? Positive pulse only. In that case, diode will be reverse bias. When diode is reverse bias, it will come to the what now? Non-conducting state. Once the diode comes to the non-conducting state, it can act as a what I said, open circuit only now. When diode is a open, this diode is a open circuit, this diode is a what now? Short circuited now. It can charge, capacitor will be charged positively and negatively and can develop the maximum voltage Vm only now. In case we are giving negative pulse here now. Negative pulse is given. What I wish to say here now? During the positive pulse, we got such a way. During positive pulse, voltage across C1 is nothing but what we are getting, the Vm only we got. Vm only we got. Next, what I did, whenever the negative pulse is given, which diode is on, which diode is off? In this pulse, what I said, D1 is on, I said, and D2 is off, I said. No doubt. You followed, I think. Second case, what I am doing here now, I am giving the negative pulse. During negative pulse, whenever the negative pulse is given, what happens now? Diode D1 is reverse bias. Positive is given to negative only now. That's why D1 is off. D1 is off means it is replaced by open circuit only. This is replaced by open circuit. What about D2? You check it. Negative is given to the negative only now. D2 comes to the on state. So, whenever the D2 is on, it can be replaced by short circuit here now. This is on. It can be replaced by short circuit. Once this diode is a short circuited now, what is going to happen now? This is with the negative polarity. Directly it will come and give the negative. Because of the induction here available the positive polarity only now. Due to negative pulse, directly negative is available. Due to induction, it is available positive. Maximum voltage here available is nothing but the Vm only. So, just a KVL you apply from top to bottom. It is available V01. So, we can say V01 is nothing but how much voltage available? Plus Vm we are getting. Vm plus Vm we are getting. That is nothing but 2 Vm is available. So, what is V01 means? 2 Vm is available. So, it can act as a what? Voltage doubler. Yes, circuit 1 acts as a voltage doubler. This is correct, no doubt. Directly we cannot say, sir, that only correct. Others are wrong, we cannot say. We need to check again. Circuit 2 also. Circuit 2 acts as voltage tripler. V03 equal to, not minus, V03 equal to 3 Vm. We can check. This is nothing but clamping circuit here now. It is also clamping only now. There is a clamping circuit here given. Diodes with capacitors it is given. In the clamping circuit, how the voltages are developed across the capacitor, you watch it now. In this case, whenever any clamping circuit is given such a way, just like a ladder network they will give. When the ladder network form it is given, you can say directly. Those first polarity is very important. That will get a polarity plus minus, plus minus, plus minus, plus and minus. That polarity only available. Directly you can put the polarity such a way. Initially, what is going to happen now? Voltage across the first capacitor in the clamping circuit, it is available. Plus Vm is available. Always. Very easy way you can do, The other capacitors, if it is taken, wherever you, whatever the capacitor you got here now, next level now. Here it is possible 2 Vm only. Here available 2 Vm. Even the other capacitor can develop the 2 Vm. This capacitor also can develop the 2 Vm only. Wherever the capacitor is given, first capacitors can have the Vm value. All other capacitors will have the voltage across them is a 2 Vm, 2 Vm, 2 Vm only. Up to n minus 1, you can find same 2 Vm only now. But don't say first one is a Vm, second one is a 2 Vm, third one is a 3 Vm. No chance. Why not possible, sir? Because the maximum voltage across the capacitor is peak to peak value of input only now. But the positive pulse plus Vm we are getting now, negative pulse we are getting the minus Vm. Vm minus of minus plus Vm, totally 2 Vm. It never comes more than 2 Vm only now. More than 2 Vm you got across the capacitors means we can say diode can act as an amplifier only. It is not acting as an amplifier. It is not an amplifier. That is why maximum voltage across the capacitor is available 2 Vm only now. Voltage across the capacitor. That's why for any clamping circuit, Vm, 2 Vm, rest of capacitors 2 Vm, 2 Vm only now. Now catch in this case. Circuit 2 acts as a voltage tripler, V03. What is V03? You find here now. But I want to find what is V03. What V03 is available from this circuit. Just apply the KVL in this direction. Just apply the KVL in this direction only. Whenever KVL is applied, the direction plus Vm is available here. Yes, I can put plus Vm. When you go to the front, plus 2 Vm is available. This is 2 Vm. Finally, what voltage is available? 3 Vm is available here. Voltage tripler. That means whenever from the clamping circuit given in the circuit 2, V03, if it is considered, it comes as a what now? 3 Vm only. So it is acting as a what now? Voltage tripler only. Yes, this is also correct. That also correct only. In the first case, we are getting the first circuit onwards. I got what now? 2 Vm. It is acting as a voltage doubler. In the second case, V03, if you calculated, we are getting the 3 Vm, voltage tripler only. So next one, option C is given. Circuit 2 acts as voltage quadrupler, that is a V02 equal to what now? 4 Vm is given. So we can check what V02 is available from the given network only now. I want to find what is V02. Apply KVL from here to here only now. Directly you can apply KVL. How we can apply KVL? I wish to find what is V02 here. I wish to find what is V02. When I move from here, plus 2 Vm is available. Yes, I can take 2 Vm only. When you go to the front, plus 2 Vm again available. Again 2 Vm plus 2 Vm is nothing but 4 Vm is available. 4 Vm is available. Totally 4 Vm is available. So it is given circuit 2 acts as a voltage quadrupler. That is a V02 equal to 4 Vm. Yes, this is also correct only now. This is also correct only, you can say. Finally, which option is correct? All of the above is a correct only now. Say all of the above is a correct. So 100% option D is correct only, we can say. So A is correct, B is correct, C is correct. So D can be taken as a solution only. All these are correct only. I hope students followed this. The solution followed or not followed. If any student has got any doubt, please arise. You can arise any doubt regarding this problem. I am ready to clarify your doubt. Any students? Any students having any doubt regarding these problems? Both are clamping circuits only. From the first clamping circuit, I got the 2 Vm. When the output is taken from the top, we are getting the what now 3 Vm. When output is taken from the bottom, we are getting the what now 4 Vm only. So that is the required problem. Nobody is having any doubts? Any students are there? So this is the solution of this problem, I can say. Understand? Now we can go to the next problem now. Yes, this is one more. This is a ground only. Yes, initially you try this question, then after I will do. Initially you try this question, then after I will do this. First, I will read out the problem. In the given transistor circuit shown below, Vz equal to 8 volts. Zener, voltage across Zener is given 8 volts. And voltage across the diode Vr is given. Voltage across the diode only, 0.7 volts, no doubt. And Vb is given, base to emitter voltage of the transistor is given 0.6 volts. The emitter current and output voltage of the circuits are respectively. Is asking output voltage and also emitter current only now. Anybody can do this question without my help? Without my help, any student can do this question? Any student? Anybody can do this? You take some time and try to give answer for this problem. What answer is available? What answer is available from this network, I say? Any student? Any student can respond? Yes, I will do, please watch. In this network, given a transistor and one diode and also given one Zener diode, is asking to find the output voltage V0. This voltage I want. That voltage I want. What about the second one? The emitter current is must. Emitter current means this current is the emitter current from the transistor. This is the emitter current. But whenever the emitter current means after reaching to this point, the same current is diverting this side. It passes through the 1K also. So IE is nothing but current across 1 kilo ohm also we can say. From the given problem, we need to find V0. V0 means voltage across 1 kilo ohm here. IE is nothing but current across 1 kilo ohm. How much is asking here now? In this problem, please watch, a Zener diode and also what not diodes are connected in parallel. Which one is operating here now? Both are operated or any one is operated? Anybody can respond? Which is going to operate? Zener diode is going to operate or diode is going to operate? No doubt, sir. Okay. Anybody can say? But in this network, VZ, what now, Zener diode is operating, otherwise diode is operating. That is my first question. Anybody can give? Raviteja, can you give answer? The before problem you said no doubt. Can you say diode is operated in the network or Zener diode is operated? Yes, normal diode is operating only. Yes. How can you say the diode only operating? Why Zener diode will not operate? That is my question. Why can't you say the Zener diode will not be operated in the network? That's my question. Anybody? Normal diode is operating, you said very good. Your point is 100% perfect, but I got a doubt. Why the Zener diode will not operate? Do you have any idea? No idea. Do you have any idea? No idea. You tell me. Yes, I will explain. Please watch. Suppose any student made an assumption. Sir, both are operating, sir. Suppose you said Zener diode is in reverse bias. Okay, Zener diode is also in reverse bias, means supply voltage is given 10 voltage. Voltage across the Zener is a 8 voltage. So supply voltage is more than the Zener. Once the Zener voltage, once the voltage at this node reaches to the 8 voltage, 100% Zener will also operate. Because the breakdown is done, it can operate. Then current also passing to the Zener diode only. Catch my point. Once the Zener diode under reverse bias receiving the voltage of Vz, immediately breakdown is done. Across the Zener diode, it is going to pass the current only. It is going to pass the current only now. So why can't you say the Zener diode also operated in this case? That is my question only. Anybody? It's a very simple answer. You listen, Ravitesa, you can understand clearly now. Suppose we made an assumption, both are answer. Suppose any student said, both are on means what is going to happen now? Voltage across this diode is a 0.7 possible here. Voltage across Zener is possible 8 voltage only. One is 8 voltage, one is a 0.7 voltage is possible in the parallel connection. These two are in parallel. Voltage must be same required. If both are operated, what is going to happen now? It is a what? The circuit is not balanced circuit only now. 100% it is not accepted only now. It is not accepted only, you can say. That is why anyone is going to operate only now. Which is going to operate? That is the question is arising here now. Which is going to operate means where we are finding the drop of less, that will operate very fast only. The diode, that means GNR or the radar, the diode which can have the low voltage drop will operate very fast. Once it starts to operate, it doesn't allow the other one to operate. So which can have the low voltage drop? Diode can have the low voltage drop only now. Whenever this node voltage is reaching to the 0.7 voltage, immediately this is going to operate. This is going to operate at 0.7 voltage only. Whenever the diode is operating, this Zener diode will not be operated only. Because which is operating at low voltage, diode is operating. At the time once it starts operating, other one will not be operated only now. Because that to operate, it is required what now? Around 8 voltage only. That much voltage will not be developed at this node only now. That is why what I wish to say, the Zener diode will not operating only now. This will not operate. This will not operate only. Finally, 0.7. Now, can you say what is this node voltage now? What node voltage is available? Same 0.7 is available here. Same 0.7 volts. It is available. But in the problem it is given directly. Base to emitter voltage is nothing but 0.6 voltage only. I say this voltage is given 0.6 voltage here. I am asking the question, what voltage we can get at this node now? What V0 is possible here? That voltage only V0 here now. Anybody can give now what V0 is available? This voltage is nothing but the 0.7. This voltage is a 0.6. What voltage is available? Difference of the voltage only available as a V0 only. Difference means this at the B base, we got the 0.7 voltage here minus drop across this transistor base to emitter is nothing but 0.6 voltage here. 0.6 voltage. Finally, we are getting 0.1 voltage it is available. So what V0 available from the given network is nothing but 0.1 voltage only we can say. Catching or not catching my point now? So difference of this voltage can give the V0. That V0 is nothing but voltage across 1 kilo ohm only. So you watch here now where we are getting 1 voltage. Do you have at anywhere 0.1 volt? Yes, we are getting 0.1 volt here only. No other one is having the 0.1 voltage only. 100% which option is correct? Option C only correct. But the student will get out, sir, what about these emitter currents, sir? Yes, we can find if you want. Yes, you watch. How to get this IE? IE is nothing but the current across 1 kilo ohm only. So I can say current passing through the emitter is nothing but, catch my point. Current passing through the emitter is nothing but emitter resistance. What now? Current passing through the emitter is nothing but voltage by resistance. V0 by 1K I can take. What V0 we got? 0.1. This is nothing but 1K, 1 into 10 power 3. And you check it, what value is available? 0.1 milliamperes it is available. 0.1 milliamperes. That equal to how much you can say? 100 microamperes we can put here now. I equal to 100 microamperes. This is nothing but 100 microamperes it is possible. So finally, which option is correct? Option C is correct only, we can say one now. That way we can determine V0 and IE. Any students having any doubt regarding this solution? Anybody? Can you say, Ravitesh, did you understand or not? If you got any doubt, please arise regarding this problem. Anybody? It's a very simple question, logically given this one now. Yes, we can go to next question here now. Yes, this is one more question. Every problem is very important. Yes, anybody can try at first. Ravitesh got it, sir. Very good, very happy then. Very good. Yes, I will give some time. Please try this. If you got answer, very good. If not getting, I will do only now. First, initially you put an effort to get answer for this question. Anybody can try this question without my help at first. You take some time and try to give answer. What is given problem? In the given transistor circuit shown below, VZ equal to 8 volts, voltage across Zener diode is given 8 volts. VR equal to 0.7 voltage drop across this. When the VR equal to 0.7 means when the Zener diode is acting, when the Zener diode is a forward bias, it can have the 0.7 voltage. It can act just like a diode only here now. And VBE 0.6 voltage only now. Base to emitter voltage 0.6 volts. Sorry, output is available. What is the output? The emitter current. Sorry, this the problem is the last question we are getting, I think. Sorry, this question is given. Yes, anyhow, no problem. The emitter current and the output voltage of the circuit is required. Is asking to find the emitter current and also is asking to find out the what now? Output voltage is required. How we can find this? Sorry, this the question is the last question only, I think, 8 voltage, VR is a 0.7 voltage, VBE 0.6 and stand up. Anybody can do this question first of all? The options also last problem only instead now. Okay, here given the options wrong only here now. Sorry, last problem values came here now. Same last problem question is given here now. These are all last problem options only. Please watch last problem also given same, I think. Yes, 100 micron, 8 voltage. Yes, that is why. But the problem here given wrong only here now. Here what is asking here is find V naught. This is only question. The question is find V naught only. This question is wrong here now. The given question is wrong here. Last problem is repeated. Same. And anyhow find V naught. V naught value is required from this problem only. Catching or not catching? Same last problem question is just here now, printed only now. But anyhow find V naught I want here now. How we can find the V naught from the given problem here? What way we can calculate V naught from the given problem? And voltage across the Zener is here now exactly. I will give now. I will modify exactly. The problem is changed here now. The values I will give. The voltage across the Zener diode is given here. I will give, just wait. 8.3 voltage here now. This is 8.3 given. Last problem values came 8.3 voltage only. That voltage. This voltage is given in the problem 0.7 only. This problem is, this is the correct problem. It is changed only these values. 0.7 voltage. Asking to find the V naught value only. Now please watch. Followed or not? This is the exact problem. Find V naught from the given problem. How we can find that V naught value here now? V naught is nothing but this node voltage is nothing but the V naught. This node voltage is nothing but V naught value only. How we can find that V naught? We need to find this voltage at first. We need to find this voltage. I selected only this network. Only this network means 20K resistance, 30K we got. This voltage, if you want to find, means just you apply KVL in this direction. Just you apply KVL in this direction. Whenever you apply the KVL, you are going to determine this voltage. Suppose I selected this voltage as Vx only. I wish to select this voltage as a Vx only. How that Vx will be calculated? Please watch. How that Vx will be calculated? KVL I applied. When I move this side, this with a polarity plus possible, this with a polarity minus is possible. Whenever you go this side, Vz is 8.3 volts. Yes, I can put 8.3 volts. Plus base to emitter voltage. Base to emitter voltage, we got as a 0.7 voltage. Yes, I am putting 0.7 voltage here we got. Finally, total Vx, what is available? 8.3 plus 0.7 is nothing but 9 voltage here available. This voltage is nothing but 9 voltage here available. This is Vx value. Now catch my point. Whenever the V0, but we want to find the V0 value only. Current will be diverted this side. From the emitter, some current this side, some current this side. After reaching to this junction, base side some current will flow. Everybody knows very well, base current is always very, very small. That is measured mostly in microamperes only. Here what I did, the current passing through the base of the transistor, I am neglecting only. Why, sir? That current is in microamperes. That current, whenever I neglected, now this current and this current will be remains constant only, same current. Whatever the current it comes, same current will flow. But this current is a very, very small, but we are neglecting that value only. Finally, the network, what we got here now, this is the 20K we got, and also 30 kilo ohms we got here, 30 kilo ohms we got. This voltage I got as a what? 9 volts. This voltage is 9 voltage here now. V0 we need to determine. We need to find that V0 value. When the same current is passing through the network, we can apply the voltage divider formula. How we can apply voltage division formula? Yes, we can apply in this way. This is nothing but Vx we said now. According to voltage division formula, Vx equal to, we can say V0 into 30 by 30 plus 20, 50 is available. 50 only. We know very well Vx value is nothing but the 9 volts. Yes, I can take this as a 9 voltage only. V0 into 30, 0, 0 here cancel now. Into 3 by 5. 3 times I can cancel here now. Finally, V0 equal to what voltage is available? 15 voltage is available. This is the way we can calculate the results. This way we can calculate only. So V0 equal to, because they don't take these parameters now. This is the last problem. What now? Options are given. Understand now? That's the wrong only now. Find V0 only here now. We need to find V0. V0 is calculated by this methodology only. Anybody has got any doubt? Any student having any doubt regarding this problem? V0 we can calculate only from this branch only by applying voltage division formula only. Understand? Yes, next one. Next. This is the next problem. It is a very good question. What is the name of this network here? Now, first, what is the given problem? Anybody can do first? First, I will give some time. Please try to tackle this question. Please make an effort to get its answer. What answer is possible from this network? What network is given? The given network is current mirror biasing circuit. Current mirror. By using the current mirror, can you find? Anybody can find? This is the current mirror. First of all, you tell me why current mirror biasing circuit is required. In any network, any constant current you want to maintain, current source Suppose you have taken any network. The emitter is connected with one current source. One current source is required at anywhere. The current source equivalent circuit is nothing but the current mirror circuit only. That current is going to maintain constant. At anywhere you want to connect the current source. By going to the any shop, you cannot buy the current source. If you ask, I want 2 milliamperes of the current source you give me, means you will laugh only now. Current source we cannot get. The current source equivalent circuit only we can say it as a what? Current mirror circuits only now. Understand now? Constant currents to maintain current mirror circuits are used only now. But anyhow, what is asking in this problem? All transistors as shown in figure are identical. That means in the problem all the transistors are identical. Identical means what now? All these are manufactured with same material only now. And also beta values of each and every one of the transistor is same. It will not be differed. Then only we can say these are all identical. Beta values also same only here now. Then collector current of Q1 and Q2 are. Collector current of this is asking to find collector current of this and collector current of the Q2. These two collector currents is asking to find only now in the collector current. How we can find collector currents IC1 and IC2? 4 options are given here now. Catch my point. The supply current is nothing but 2 milliamperes. In the given problem, supply is connected with 2 milliamperes. When the supply is connected, this side IC1 is going to pass. What current will pass this side? Some IX. IX we can assume. What is that IX? We can see. After reaching to this junction, what is going to happen? Current is divided. In how many ways? 3 ways. We are going to say this current is nothing but the IB1, for example. This is IB1 I have taken. This side IB2. Transistors are what? Made up of same material only, identical. Identical means what is going to happen now? This side current or that side current or this side current. 3 currents will be IB1, IB2, IB3 are same only. Why it is same, sir? Reason is what? Because these are all identical. Even you applied the what now KVL voltages are same this side. Even this side voltage is same. Even you go this side, this voltage also same only now. VBE values are same. Base currents also same only now. I say if it is a IB1, I can say this current also IB1 only. This current also I can say it as IB1 only. IB1 only. Even you have taken IB1, IB2, IB3. IB1 equal to IB2, IB2 equal to IB3 only. These 3 currents are same in the network only now. But my aim is to find out IC1 and IC2 only now. But what is IX here? IX is nothing but this current plus this current plus this current. Addition of these 3 currents equal to 3 IB1 also I can write. 3 IB1 also I can write in this problem. And now can you find IC1 from this? Can you find? How we can find? This is the 2 milliamperes are dividing here now. After reaching to this point, it is divided. Some current this side, some current this side. I can write 2 milliamperes equal to 2 milliamperes of current equal to what? IC1 plus IX. IC1 plus IX, no doubt. We got already what is IX is given in the problem. That I can substitute directly. 2 milliamperes this side. 2 into 10 power minus 3. IC1 I wish to take as it is only. What is IX? IX is nothing but 3 IB1. In the problem we got it. So IX is nothing but 3 IB1. Yes, we can write 3 IB1. So IC1 plus 3 IB1 is equal to 2 milliamperes. Up to this extent, anybody has got any doubt? If there is any doubt, please arise. Total current is divided into what now? 2 parts, IC1 and IX. IX is divided into 3 ways. IX equal to 3 IB1 I have taken now. In this case, IB1 I wish to convert in terms of IC1 only. I can write, we know very well, base current equal to IC1 by beta only now. IC1 by beta, we know very well. In BJT it comes that. I can write 2 into 10 power minus 3, 2 into 10 power minus 3 equal to IC1 plus, I can note down IC1 here, plus 3 into IB1 equal to IC1 by beta. Yes, I can write 3 IC1 by beta, I can write. Such a way we can write. Such a way we can write. There I can take IC1 in common. I say 2 into 10 power minus 3 is taken as it is. I wish to take IC1 in common. If I have taken IC1 in common, I can get 1 plus 3 by beta only. 3 by beta is available. My aim is to find IC1 only. But how we can find the IC1 then? IC1 equal to, we can write directly 2 into 10 power minus 3 divided by 1 plus 3 by beta. Beta is given in the problem. How much? 250. Yes, I can write. Beta is nothing but 250. Yes, we got 250 value, this one. And use the calculator and you will get the what now? IC1. Any student can give answer. What answer is available? Anybody? Mostly it comes 1.97 milliamperes you will get. 1.97 milliamperes you will get. If you are using the calculator, 1.97 milliamperes of current is possible. That much IC1 is possible. That much IC1 is possible. Yes, we got the IC1. That means the collector current at Q1 I got. Anybody can say at Q2 what is available? What current is available? Same current only. IC1 or IC2 or even you have taken IC3, it comes same only. The student may get a doubt, sir, how these three currents are equal, sir? How can you say IC1 equal to IC2 at first, sir? Base currents are same. Beta values are same. IC2 equal to, IB1 into beta only. Beta into IB1. Even IC1 also what? Beta into IB1. Even IC3 also beta into IB1. Finally, all the collector currents are equal. It will not be differed only now. So even at Q2, that even for the what now Q2 transistor, it remains same current only. Even IC2 also here 1.97 milliamperes only possible. Sorry, I'll write just wait. IC2 also 1.97 milliamperes only. 1.97 milliamperes of current is going to pass only now. That much current is going to flow only now. So which option is correct here now? Option A is correct in this problem. 1.97 milliamperes. Even second collector current also 1 is not correct now. Sorry, 1.97 where you are getting? Yes, I'll just wait. 1.79 milliamperes, 1.9 where available. Yes, that only possible now. 1.97, 1.997 is given. This is not 99. This is 1.97 only possible. So exactly option A only correct. 100% correct this one. Yes, that way we can get answer only. This is 1.97 milliamperes, so the current is possible. Anybody has got any doubt regarding this problem? Any student has got any doubt regarding this problem? That way we can tackle this question only now. Next one. Next problem. This is one more question. But initially you make an effort to get answer for this question. If you are getting answer for this question, just you message it. Which option is correct out of these four? Which option is right? Can you give answer? You take your time and try to do this question. If you are getting answer, it means very happy. Understand? What is the name of this circuit first of all? What is the name of this network? The given network, they are only given Darlington pair. Darlington pair can also be called as a Darlington amplifier, no doubt. Anybody can say what is the purpose of Darlington amplifier? Why we are going to use practically Darlington amplifier? The purpose of Darlington amplifier is to produce the more current gain. More current gain. Whenever you want to get, you need to use the what now? Darlington pair only. The student will get a doubt, one more doubt it is going to arise. Sir, common collector amplifier is going to do what now? More current gain. Common collector amplifier can give current gain of the more. At the time, why it is required? Why it is required? Darlington amplifier. One more doubt is going to arise. But what is the Darlington amplifier means exactly? The cascading of two common collectors are made. Cascading of two common collector amplifiers are made. At the time, it is going to form the Darlington amplifier only. That means cascading of two common collectors only. The student will get a doubt one more. Sir, you corrected the common emitter amplifiers are here now. How can you say here this is a common collectors are cascaded only? Practical circuit is what? This will be connected with what now? The emitter will be connected with what now? One resistance only. They will connect only now. They will connect like this. One resistance they will connect for amplification. They are going to receive the output across this only. Such a way output is received from the network only here now. Understand now. When the output is received across this one now, emitter is grounded here now. Output is taken from the emitter resistance only. There is no RC, collector resistance is not given. The network can act as a what? Emitter follower only. This network is nothing but exactly emitter follower. Emitter follower, it can act as a what? Common collector amplifier only. Emitter amplifier, but now emitter follower can act as a common collector amplifier only. That is why finally it can act as a what? Common collector amplifier only now. That is why Darlington amplifier, I am removing this now. Understand? Anyhow, you followed, I hope, what I said. What I said here, cascading of two common collectors are made at the time it is going to form the what now? Darlington amplifier. In the given network, emitter follower is selected only now. Emitter follower can act as a what? Common collector only, I said now. Anyhow, this is Darlington amplifier. But this Darlington amplifier, and from this amplifier, what is asking to find? The HFE, each transistor in Darlington pair, as shown in the figure, has HFE equal to 100 is given. HFE equal to 100 means it is a beta value only. Beta is for each one, it is given beta value 100 itself. The beta value for each transistor is 100, it is given directly in the problem only. And overall HFE of the composite transistor neglecting leakage current is, overall HFE is required from the given problem only. How we can find the overall HFE is more important. How we can form? You try to catch. In this Darlington amplifier, this current is taken as IC. That I want to take it as IC only. The current passing through this side is taken as a what now? IB. This is the base current is available. This side base, that side IC only. This IC is divided into what now? IC1 and IC2 here. IC1 and it can divide as a IC1 and IC2 only. IC is divided as a IC1 and IC2 here. This current I want to denote IX. I selected IX. IX can also be said as a what now? Emitter current of the what now? First transistor. Emitter current of first transistor. Otherwise, we can say IX can also be said as a what now? Base current of the second transistor also. This can also be said as a base current of the second transistor also. That is IX only now. Here overall HFE means what is the meaning? I can say overall HFE is nothing but beta equal to what we are going to take? IC by IB you are going to take. In the same way here also IC by IB. Overall means total collector current by total base current. This is called as a overall HFE of composite transistor, we can say now. That much is possible. How we can find that ratio? In this problem, IC equal to what? how we can take IC value. IC is divided as a IC1 and IC2. So I can write IC is nothing but IC1 plus IC2. IC1 plus IC2, it is possible here now. IC1 plus IC2 is nothing but IC1. Here, IC1 equal to, everybody knows, every student knows now, beta into IB only. What IB? This basic. For the first transistor, IC1 means collector current of the first transistor only. Collector current of the first transistor is nothing but beta times of IB only now. I can note down beta times of IB. Beta times of IB is nothing but IC1, I can say. What about IC2? IC2 is nothing but beta times of base current of this transistor. I have taken IX only. I can note down IC2 is nothing but beta times of, what is required? IX I can write. Beta times of IX. That is nothing but IC value. But I want equation in terms of IC and IB only. We got IC, IB and IX also. Here IX is nothing but the emitter current of the first transistor. IX is nothing but the emitter current of the transistor. Otherwise, IX can also be taken as a what? IX is nothing but emitter current of the first transistor. Otherwise, we can say base current of the second transistor also. We can say base current of the second transistor. Emitter current of the first transistor, how I can find? 1 plus beta times of, you know very well, IE equal to IB plus IC. From that I can say 1 plus beta times of, what is available? IB. 1 plus beta times of IB is nothing but IE1 only. IE1 depends upon this IB only. That's why 1 plus beta times of IB is nothing but IE. That IE1 is nothing but IB2 only. Yes, I can substitute here now. IC is nothing but beta into IB here plus beta into IX. We got IX. What IX we got from the problem? IX is nothing but 1 plus beta into IB. Yes, I can write 1 plus beta times of IB we are getting here now. What ratio is required from the given problem? HFE is nothing but IC by IB. IC by IB is nothing but HFE. Yes, I want to divide by IB. Then I can get HFE. Overall, HFE is required. That is nothing but IC by IB, I said. IC by IB only, I said. IC by IB, we are getting finally beta plus, yes, we can write beta plus, what more else we are having here now? Beta into 1 plus beta. Beta into 1 plus beta. We are getting that much value of HFE is available. So that HFE I can determine by substituting the beta values here now. Yes, I can put those beta values in this one. I wish to find what is HFE. That HFE can be calculated by beta is 100, that 100 I can put here now. Plus beta is nothing but 100, one more 100 is there here now, that I can put directly. 1 plus beta is nothing but 101 we can get here. Just use the calculator, you are going to get the HFE one. If you are using calculator means it comes as, the value will be, this is 100 no doubt, 100 into 101 if it is taken 101000, 10100 is possible. Whenever you are adding this value, it comes as 10,200 is available. 10,200 is available. That much value is possible. Finally, which option is correct? 10,200 means option D is correct from this problem only. This option is right. Such a way we need to tackle this problem. Did you understand or not? Any students can respond. Did you understand this solution or not? If you got any doubt, please arise. If you arised any doubt means I can clarify. If any student has got any doubt regarding this problem, they can arise. I will do then. Yes, we can go to next question. Yes, this is the next question. Yes, anybody can do this question? I will wait then. Please start doing this problem. Initially, you try to get answer for this question. I want to give you some time. Please try this. What answer you can get? The question is what? The value of DC bias voltage VC in the circuit shown in the figure is dash. Is asking this VC value. Beta is given 45. Capital VC, collector voltage means under DC analysis only is asking to measure the voltage under DC analysis. They are not allowed any AC analysis, directly given in the problem. V suffix C, collector voltage is required. Collector voltage we can find under DC analysis only. They are not allowed any AC analysis. When you can apply the AC analysis, whenever in a problem you are asked voltage gain or current gain or input impedance or output impedance, then you can use the AC analysis. Then AC equivalent of the circuit is required parameter you can find. But in this problem, it is not asking any AC parameters, it didn't ask. It is asking to find the collector voltage. That collector voltage we can find directly by using the DC analysis only. Yes, you start doing this work. You do it and find the value. Anybody? Anybody can do this? Yes, I will do. Please watch. I said just now, this collector voltage can be determined by using the DC analysis you got. Under DC analysis, what is the condition is applicable? Wherever AC source you got, that must be short circuited. VI is the AC source, that must be shorted one. Wherever capacitors are connected, they must be open circuited. Wherever capacitors are connected under DC analysis, it must be open circuited only. Wherever AC source is given, that must be shorted one. Then the equivalent circuit can be plotted in this way. There is a transistor. There is a transistor here. The transistor is connected with 1.2K resistance. 1.2K resistance here. 1.2K resistance. And this is connected to the ground. This is connected to the ground only here. That's connected to the ground. The capacitor must be open circuited. If it is open circuited, what is going to happen now? This point voltage is VC only. This voltage we say it as a VC only now. The transistor I have drawn as this is connected to the emitter is connected to what voltage? -9 voltage. This is connected to -9 voltage. That one. This side, this capacitor is a open circuited only. This is open circuit. This is open circuit under DC analysis. So whenever it is a open circuited, now 100 kilo ohms we can get here now. Here I can get 100 kilo ohms. I will get 100K here. 100K. That is connected to the ground. This is connected to the ground. Finally, the network is formed. Here in the problem it is given beta equal to 45. This beta is given 45 only. Beta is given 45 only. Now, how we can measure VC? If you want to find the VC, this collector current is more and more important. Collector current is required. Once I got the collector current, I can apply the KVL in this direction. I can apply the KVL in this direction. Directly, I can apply the KVL in this direction only. That way I can apply the KVL only. But here IC is unknown. IC depends upon what factor? IC depends upon the base current only. I can draw this current is nothing but the base current. This current is nothing but the base current only. And I can apply the what? KVL in this direction. If I apply the KVL, I can measure the IB value. Once I got the IB, I can measure IC value. How to measure IB? When I apply the KVL, 0, this is the voltage, 0 voltage. Yes, I can put 0 voltage. This is the base is connected, ground is a 0 voltage. When you go to front, 100K into IB, 100K, 100 into 10 power 3, 100K into IB, plus voltage drop across these 2 points. VB is not given, you know very well, 0.7 volts I can put. This voltage is 0.7 voltage only. After that, when you go to front, -9 voltage here available. I can connect -9 voltage directly here. Applied KVL. Now we can measure the base current. The base current is nothing but 9 minus 0.7 minus 9 is nothing but 8.3. So we can get 8.3 by how much? 8.3 by 100 into 10 power 3. 100 into 10 power 3. Use calculator and find what is IB. You tell me what IB is available. What IB is possible here. What IB is possible. But if you are using calculator, means exactly it comes 83 microamperes you will get. 83 microamperes you will get. That comes as 83 microamperes. If you are using the calculator, base current you will get 83 microamperes is possible. 83 microamperes only. Once you got the base current, you can measure the IC. The collector current is nothing but what? Beta times of IB, we know very well. IC equal to beta into IB, no doubts. What is beta? Beta is given in the problem 45. Yes, I can write this as a 45. And what about IB? IB is nothing but 83 microamperes. I can put 83 microamperes only, I can put now. Whenever you are using the calculator, you will get IC value. That IC is nothing but, it comes as 3.735. 3.735 milliamperes mostly possible. Milliamperes of current is possible. 3.735 milliamperes of current is possible. Yes, we got IC. But by using this IC, I can measure VC only now. Just I want to apply the KVL this side. This side, whenever you used 0 equal to, I can take 1.2K into IC, 1.2K into IC. What IC we got here now? We got IC is nothing but 3.735. 3.735 milli. Milli means 10 power minus 3, I can write. 10 power minus 3 we got. Plus VC we got. Yes, I can write plus VC. The what VC is available here. Now you calculate. Use the calculator and find what VC. Here you can get. That VC comes as minus 4.48. Minus 4.482. That was approximately 4.48 approximately. That much voltage is possible. So which option is correct? Minus 4.48 volts is nothing but option A is correct only, you can say. Option A is correct from this problem. In this way, we can determine collector voltage from the given network. Follow this? Anybody has got any doubts regarding this problem? Regarding this solution, if you got any doubt, you can ask. I will try to clarify your doubts. Anybody? Followed or not followed? Anybody? Can you respond? Yes, I will do the next question. This is the next question. The first trial is yours. Initially, you try to get answer for this question. Initially, you try. If you don't get answer, I will do. Start doing this problem. What answer is possible? You try it. Anybody can do this? Number of Zener diodes are connected. Says in the problem what is given, in the circuit given below, assume that VCC equal to 15 volts, Z1, Z2, Z3 and Z4 are identical Zener diodes. All the Zener diodes are identical, it says. With breakdown voltage of 5 volts. Breakdown voltage, that means VZ value is given for each diode is 5 voltage only. R1 equal to R4. R1 equal to R4 is given. That means R4 is how much is given? 5 kilo ohms it is given. 5 kilo ohm. R2 equal to R3, 10K. R2 is given 10K. R3 also same resistance. I can take 10K only, 10 kilo ohms only given. R1 is not required anyhow, you know. When find V0, when Q1 is off, is asking to find this V0 is how much? What is V0? When Q1 is off means what is the meaning? Transistor is off. Transistor is not operating. When transistor is off state means you find out the V0 value. When transistor is not working means the current whichever it comes from the supply will go to the what? No, other diodes only. Currents are passing to the diode. But don't say V0 is nothing but 0, sir. Otherwise, V0 equal to VCC, sir. Don't say that. VCC is given here 15 voltage here. This voltage is given 15 voltage here now. How we can find this V0 is very important. How we can find this V0 means this is V0 means this node voltage also V0. Even this node voltage or this node voltage is same only. V0 only possible. By applying the nodal analysis, we can find V0 value. How we can apply the nodal? You take the direction of the current away from the V0. Away from the V0, nodal. This is a conventional direction. For our convenient purpose, we are putting these directions. This current plus, this voltage also same. This current plus, this voltage also same. This current equal to 0 only. Summation of all the currents equal to 0 only now. That is the nodal. As per nodal, how I can find the top current, whatever it goes is nothing but this current equal to, current direction is top, V0 minus 15, I can write V0 minus 15 divide by resistance. What resistance? 5K is given. Totally kilo, all are in kilo only. That will be cancelled. Plus this plus current passing to the R2, how much? This Zener, what now? Voltage across this Zener and this Zener is same. Even this node voltage also remains same only now. Those two are same parallel. Voltage same, that node voltage, how much it is possible? 5 voltage only. Voltage across the Zener is a 5 voltage. Even this node also 5 voltage only possible. Voltage across each diode is what? Zener diode is a 5 voltage one. Now I can apply. This current is nothing but V0 minus 5. V0 minus 5 divide by resistance. What resistance is existing here now? 10K only. 10 I have taken. Plus one more current is passing. Which current? This side current across R3. What current is passing? V0 minus 5 by 10K I can put. I can write V0 minus 5 divided by how much? 10K only. Kilo will be cancelled totally. Summation of all these currents equal to what I said? 0 only, we said no. I can cancel 2 times, I can cancel now 5, 5 2s I can cancel here, 5 2s I can cancel over here. That way we can cancel. I can take LCM here now. 2 is LCM, 2 V naught here. We will get 2 V naught minus 2 into 15, 30 is available. You will get 30 here plus V naught here minus 5 plus V naught minus 5 I can get. This is equal to what? 0 only. 2 V naught minus 30 plus V naught minus 5 plus V naught minus 5 is available. That is the equation we formed. We can add 2 V naught plus V naught plus V naught. 4 V naught is available. My aim is to find the V naught only. 4 V naught is available. What about the constant? Minus 30 minus 35 minus 40 equal to 40 is available. Equal to 40 is available. So finally, V naught equal to how much voltage? 40 by 4 is nothing but 10 volts we can get only now. So V naught equal to 10 voltage is possible. Here options are not given or not given? Yes, given. Which option is correct? Option C is correct only, we can say. This option is right. 10 voltage only. Just by applying the nodal analysis, we calculated V naught from the given problem only. Why, sir? What about this current, sir? Across the transistor, sir? No current will pass. Why, sir? Transistor is off. When the transistor is off, it won't go any current what now? To the down direction only, you can say. This is the solution for this problem. Anybody has got any doubt regarding this problem? If you got any doubt, you can arise. You can arise if you got any doubt regarding this problem. Anybody? If you don't have any doubt, means I can go to the next level. Yes, Ravit is exactly clear, sir. Very good now. Yes. Yes, such a way, if the students are responding, means immediately we will also get the more happy. And we can understand the students are really following or not following, we can understand my point now. So 100% you followed, I hope it now. Very happy. And we can go to next problem then. Next. Yes, this is one more question. Yes, I will give initially in your hand. You make an effort to get answer. Initial work is yours. Please try this question. Initially you try. If you don't get, I will do. Which option is correct out of these 4? Anybody? Yes, I will complete. Please watch. An amplifier has mid-frequency gain A0 equal to 150. The gain of amplifier is given. How much? 150. A0 means open loop gain only, not feedback gain. It is a open loop gain is given 150. And upper cutoff frequency FH equal to 50 kilohertz. That frequency is nothing but the high cutoff, upper cutoff frequency 50 kilohertz. Before the feedback or after feedback? Before feedback only, not given any feedback so far. And lower cutoff frequency is given FL equal to 40 hertz. That is also what? Without any feedback is given. For feedback factor beta equal to 0.1 is given. The upper cutoff frequency with negative feedback is, that means whenever the negative feedback is given to the what now given amplifier, you find out the upper cutoff frequency. That is the question. Is asking to find upper cutoff frequency when negative feedback is applied. How we can find? I think you know very well. Whenever you have taken the what now gain versus frequency diagram, whenever you have drawn, it comes mostly in this way. It goes like this only. The gain is going to increase initially, then after it decreases only. That gain without feedback only. Whenever the feedback is applied, negative feedback can increase the gain or decrease the gain. Any student? Because of the negative feedback, gain will be reduced or increased? That's my question. Any student can give answer? Because of the negative feedback, gain of amplifier will be increased or decreased? That's my question. 100% it decreases. Negative feedback always decreases the gain only. That means when the negative feedback is given, gain is reduced. That means it goes like this, gain will be reducing only. Initially, this is going to remain as a what now? FL only. This is going to remain as a what now? This is the some point FL low cutoff frequency, and high cutoff frequency FH, it is going to exist only now. When the feedback is given, low cutoff frequency will come to down. After feedback, FLF is available. After feedback, this cutoff frequency also changes only. FHF is available. What I wish to say, after feedback, low cutoff frequency will be decreased after feedback only. Whenever you are giving the negative feedback, high cutoff frequency will be, upper cutoff frequency will be increase only. FHF, I said, increases only. Sir, increases and decreases. Finally, in the problem, what is asking? FHF is asking to find. FHF equal to how much? Is asking upper cutoff frequency required when the negative feedback is given. Now, you tell me, when the feedback is given, FH is increasing or decreasing? F is increased or decreased? FHF is increased. FLF means decreased only, you can say. But whenever you want to find the FHF, increased means 1 plus A beta times you have to multiply. A naught is given 1 plus A beta, just wait. What I say, FHF means 1 plus A naught beta into what? FH it is to be taken. Sir, why you are multiplying? Why you are not dividing, sir? Multiplication, whenever it is made, FHF will be increasing as compared to FH. When you are dividing by the scale factor of 1 plus A naught into beta, it is going to decrease only. Practically, otherwise from the figure, it won't be decreased, it is increasing only. Suppose I ask the question now, sir, what about the FLF? FLF is increasing or decreasing? FLF means it is decreasing only now. Lower cutoff frequency, after feedback, it is going to reduce. Reducing means you need to multiply by the scale factor of 1 plus A beta, or you must divide by the 1 plus A beta only. You must divide. Whenever you are, that means FL by 1 plus A beta, if it is taken, you will get the FLF. FHF it is required means 1 plus A beta times of what? FH is to be taken. Finally, product is required for the sake of increasing the what? This upper cutoff frequency. Now I can write FHF is nothing but 1 plus A naught open loop gain of the mid frequency gain is given here. Now mid frequency gain is given, not open loop, sorry. Mid frequency gain is 1 plus beta, 150 is given here now. 150 is given here now. And beta is given as a what? The beta is given as a, we can write, beta is given as a, how much beta? Beta is given 0.1. 150 into 0.1 I can put. FH is given in the problem. What is FH? FH is given as a 50K. Into 50K I can note down. 50K, 50 into 10 power 3. Use calculator, you will get the FHF here now. You will get FHF. Upper cutoff frequency after feedback is available. This is available 800 kilo ohms. It is available. 800 kilohertz, sorry. 800. I can write 800 kilohertz it comes. When you are using the calculator, that value comes as 800 kilohertz only now. So which option is correct? Option C is correct in this problem, we can say. That is the required answer for this problem. I think students followed this solution. Any doubts, anybody? Followed or not followed? Please respond. Did you understand this solution or not? Anybody has got any doubt? Why it is increasing? There I explained by drawing the diagram. Understand now? Is the gain decrease? 100% correct, Raviteja. When the negative feedback is applied, gain is decreased. Correct only. 100% correct. Shall I go to the next question then? Yes, we can go to the next question then now. Yes, the next question. Anybody can do this question? I want to give some time. Please try this. Yes, I will complete this question. Please watch. In what way we can do? What is given problem? The voltage gain Ri and R0 with feedback for voltage series feedback having A equal to minus 100, A is given minus 100. Ri equal to 10 kilo ohms, R0 equal to 20 kilo ohms, feedback factor beta equal to minus 0.1 is 4 options are given, which is right. What is given in the problem? Ri is given, no doubt. We can note down first. What is the data it is given? You can note down. Then you will get the clear concept. No need to muck up any formula. Easily I will explain. Given A equal to minus 100. Minus 100 is given. Gain is given. Ri is given 10K, no doubt. Input resistance or input impedance is given 10K. This is given 10K only, or 10 kilo ohms, no doubt. And here R0 is given 20K. R0 is given 20 kilo ohms or 20K. We can put here now. Feedback factor is beta is given. Beta is given as a minus 0.1 is given. That is beta value. What is asking to find? Voltage gain is required. Voltage gain what? With feedback. With feedback means AF. I want. How much? First question. AF. Ri is required after feedback. After feedback, Ri becomes RIF. What is RIF? And also asking to find R0. R0 also required. We need ROF also required. These are the 3 parameters are required from this problem. How we can determine these 3 parameters? Please watch. Everybody knows in the negative feedback, feedback gain AF equal to what is the formula? A by 1 plus A beta, everybody knows. A by 1 plus A beta applicable. Because the gain is reducing after negative feedback. Gain is reducing means A must be divided by the scale factor of 1 plus A beta. Is it to be multiplied? Divided only. Whenever you are dividing, the feedback gain will be decreasing. That's why negative feedback will decrease the gain only. It's given A value. A equal to what is given? Minus 100 is given here. And 1 plus A beta. What is A? A is nothing but minus 100 is given here. This is given as a minus 100. What about beta? Beta is nothing but minus 0.1. Yes, it's given minus 0.1. Use calculator, some value you will get now. That value is nothing but minus 9.09 it comes. 9.09 gain is available. Minus 9.09. Minus 9.09 means option A only correct, I think now. The remaining are not required. But I will do how to get now. And also required RIF and RIF is required and also ROF is required. What is the type of feedback is given? Voltage series. It is specified in the problem. Voltage series. But a formula how we can take, please watch. This series indicates input circuit. This series indicates input circuit only. Voltage indicates output circuits. Output circuit only. In any problem, identification is very simple. Voltage series, voltage shunt, current series, current shunt. The second word, whatever it is given, indicates input only. The first word which is given indicates output only here now. Now catch my point. How to apply the formula, please watch. No need to muck up anything here now. I want RIF. Yes, we want RIF. after feedback, what input impedance is available or input resistance is required. So you tell me input impedance will be increased or decreased after feedback. Initially Ri. Whenever you are applying the negative feedback, RIF is available. That RIF increases or decreases. We can check easily now. Input is nothing but the series. In the series connection, total resistance will be increased or decreased. That is my question. In the series connection, total resistance will be increased or decreased. That's my question. 100% students will say increasing, sir, when it is in series only now. Suppose in the place of series, it is given the what now? Shunt. Shunt connection is given. Voltage shunt feedback, suppose you are given. Shunt indicates input. Shunt means in the resistance in the parallel connection will be decreased. That is why RIF will be decreased. That is why you can say increased or decreased RIF depends upon this series or shunt only. Anyhow, in the problem it is given series. Whenever it is given series, 100% total resistance will be increased only now. Total increased means it is multiplied by the scale factor or divided by the scale factor. Must be multiplied by the scale factor. Why it should be multiplied, sir? In the series connection, resistance must be increased. That is why RIF, how I can take 1 plus A beta times of 1 plus A beta times of Ri, I can note down. Sir, I will not take, sir, I will divide by 1 plus A beta, sir. If you divided by the scale factor, RIF will be decreasing only now. That's why it should not be decreased. We must multiply only. Then I can write 1 plus A is given as a what? Minus 100 here. A is given minus 100 here. And beta is given as a what? Minus 0.1. Minus 0.1. Multiplied by how much? This is multiplied by Ri. What is Ri? 10K. It is given. Into 10K it is given now. Whenever you are using the calculator, you are going to get RIF only. What RIF is available, you check it. If so, use calculator. RIF comes as 110 kilo ohms. 110 kilo ohms it comes. Just use the calculator, you will see the now. Anyhow, we are getting RIF 110. R0 we can check. What way we can calculate? R0 I want. How we can find R0, sir? R0 how I can get? Output is nothing but voltage is given here now. Output circuit, voltage indicates output, I said now. Voltage means what? Shunt connection only, voltage will be same. Voltage indicates shunt. Current at the output indicates series. In the series connection, current is same only now. Voltage, whenever it is given, the output circuit is with shunt only now, shunt connection. Parallel otherwise. In parallel connection, resistance will be decreased or increased. Voltage, whenever it is given, it is a parallel. Parallel means total resistance will be decreased. Whenever it is decreasing, ROIF, I can write 1 plus A beta, sorry, it must be divided only here now, is it not? And I can write this way. I can write like this. ROIF will be decreased only now. R0 divided by 1 plus A beta, I can write. Why divided by the scale factor? Output circuit is a voltage. Voltage, where we can find the voltage? Equal in the shunt connection only. There is a voltage when it is given shunt connection. In the parallel connection, resistance will be decreased. That is why it is divided by the scale factor. What is R0? R0 is given as a 20K. This is given as a 20K here now. 1 plus A. What A is given? Minus 100 is given here now. That I can put as it is. This I can put as it is. And what about the beta? Beta is nothing but minus 0.1. Minus 0.1 I can put here now. Use calculator, you are going to get some value, ROIF. That value comes as 1.82K, approximately equal to 1.82K you will get exactly. Approximately. Mostly 1.818 something will come. Approximately 1.82K. So which option is correct? Option A is correct, we can say. In that way, we can do this question. Followed or not followed? Anybody has got any doubt regarding this solution? If there is any doubt, please arise. You can raise your doubt. If any student has got any doubt, they can ask. These are the problems. Today, I made an effort to give the solution only. In the next class, we can see the problems on MOSFET, problems on the what now? Operational amplifier. You are going to see only now, understand now. Thank you then. Thank you all. I hope so far you followed very well, I think now. Understand now. We can close the session. The next class, you can see the different model circuits only again. Bye then.